Hey folks, welcome back to the channel and back from my adventures up north. Here for another edition of Office Hours, back in the office as you can see. I have to say I was, after going north and now being back here, I feel like I was promised some actual springtime, and Florida is not delivering it at the moment. I think the high today maybe is going to be like 70 Fahrenheit, so that's like 20-ish, maybe 21, somewhere in there on the Celsius scale. And then I don't know, the low last night I believe was like 50 or maybe even a little less, which would be like 10 degrees for those of you in the rest of the world. So not exactly warm, not exactly Florida style as I would prefer. So I had to bust out the hoodie today to try to make it through. So, anyways, I thought, hey, let's do some office hours. Nothing warms my heart like answering Postgres questions. So, um, let me go ahead and just jump on into that, and we'll see where that gets us. Hopefully, someplace good. The first question I've got is, can we have multiple schemas in one database using Postgres, like in MySQL? And that last piece of the question, that like in MySQL, makes it it's a very important part of the question. In terms of like basically all the major data, you think like Oracle, SQL Server, Postgres, MySQL, SQLite. So I think of those like sort of top five on the relational side. They all kind of handle the notion of databases and schemas a little bit different. So it makes and the terminology is kind of intermingled. This is one I probably should have wrote this answer down first, because I can just imagine like I'm going to attempt to explain the difference here in live time, but the wording is very confusing. So in MySQL, and as always, correct me if I'm wrong, but I'm pretty sure that I'm going to use this terminology correctly. So imagine you have a computer, right? That's got your OS on it and whatnot, and then you're going to have an instance of MySQL that's running on that computer. And when you connect to the instance, you connect to a thing that is called a database. And within that database, uh, there are, so you can connect to, let's say, more than one database. So you connect to a database within MySQL, and you can see all the other databases that are running in that instance. And you can query across those databases. But within a given database, there really is no extra sort of level of namespacing. And what do I mean by namespacing? Well, in the Postgres world, if we try to use that same terminology, it doesn't quite map cleanly. This is the problem. So the short answer is no, you can't do this like MySQL. And the longer answer is what I'm sort of trying to give to you here. And the reason is there's a little bit of a workaround, but it depends on what you want to get out of it. So in the Postgres world, like, so you imagine you have your computer, you have an instance of the software that is running, that is Postgres. And in Postgres, when you connect to a database, uh, those databases, you can have more than one running within a given instance, right? So you've just got the one sort of master, postmaster process that is running, and you can create multiple databases within that. But within each database, there's a thing called a schema, which is kind of like a namespace within that database. And so in Postgres, those databases are isolated from each other. So you cannot query across the databases, short of some external tricks or whatever. But by and large, like, just once you're connected to a database, you're connected to only that database. You have to open a new connection to get to something else. But you can query across these schemas, just, like anything else. And that's kind of similar to how it works in Oracle. I'm trying to remember how SQL Server does it. I think SQL Server actually is a little bit more like MySQL, and SQLite is a little bit more like MySQL, in which there's only like one database. DB2 is more like Postgres, if you remember. I don't know if that counts for anything anymore, DB2, but so there's kind of like two main ways that this is done, where you connect to a database. Within the database, there are schemas, and you can query across those schemas, and then you have like your individual tables and views and whatnot in a given schema. And so the reason why this becomes an issue is that in MySQL, because you can create databases and then query across those. If you want to do that in Postgres, the question is sort of, well, what about that are you trying to accomplish? And hopefully it's one of the two things, and if you intermingle it, you're in trouble. If what you're trying to accomplish is I want people to connect to the instance and then have their own database, right? So in MySQL, the way you would do is you connect to a database, and then people will be kind of locked into a particular database, and it kind of uses the what's really tricky about this is it intermingles the word database and schema depending on where you're looking in the MySQL world. So um, probably what I'm saying actually makes a little sense to someone coming from MySQL. I'm a little concerned about that because I assume whoever asked this question is coming from the MySQL world, and they're like, "Why are you talking about it in this way?" Like, I think both make sense. Both models to me make sense pretty well on their own, and then they just run into trouble when you try to explain like how they map to each other because it really, like I said, they just don't map cleanly. So if you want to be able to do like sort of the cross database thing, queries like you had in MySQL, then the way you do that is you have everybody connect to a specific database in Postgres, and then everyone would get their own schema, right? So their own namespace, and then you could query back and forth across those schemas. And you can kind of lock down schemas pretty well. Um, if you need to do that, similar to how it's done in MySQL at the database level, so that people can't see so that a general user, like a user, can log in and only see their schema, right, within a given database in the Postgres side. And then you could have, like a reporting user that can query across all the schemas. So you can set that kind of thing up. So there are kind of ways to do it, but you really have to kind of understand like what were you trying to get out of that. If you want everybody to have different connection credentials, that's where it gets tricky because in Postgres you would really need to have everybody in their own database, and then you're going to lose that cross database querying capability. So, like I said, the hard part about that is kind of mapping it because the terms are used interchangeably, excuse me, between the different databases. So, um, but if you're trying to do one of those two things, like you can kind of make it work in Postgres. It's just a little bit different. Uh, yeah. So hopefully that's helpful. Um, and hopefully that kind of makes some sense. Otherwise, I would say, like I said, map out what is the specific thing you're trying to accomplish. If you're just porting, usually what most people do is uh, they port in, and then everybody gets different roles instead of which you normally have anyways. But your sort of port and database name and all that end up being the same across those users, which would not be that way in MySQL. So. Okay, so let's go to the second question. Let's get out. Somehow, I think next question. There's a couple of different ones from other databases today. It's just kind of interesting. So, how do I convert SQL Server Stored Procedure to Postgres? Um, there are some tools that are out there, and uh, I think how well they work. This is always sort of thing. So, like in the Oracle world, like EDB has their conversion stuff, and they do some Oracle functionality. And there's a new thing that came out. It was announced during Past Data Summit, but not at Past Data Summit last year. So this is like November last year. This thing called Wilton DB. I don't actually know that much about it. They've been a little secretive, I guess, as to what they're doing. But it's essentially taking Amazon's Babelfish open source tooling and spiffying it up, making it work better on Windows, as I understand it, and I think adding some additional compatibility, and then releasing that as a product. And not an open source product, I don't believe. Um, but built on that open source work from Amazon and then the upstream Postgres. So the Amazon thing, Babelfish, I definitely would say take a look at that. It's not actually meant to be. So this is if the question is about SQL Server stored procedures specifically, like there's not really a conversion tool for stored procedures. It's supposed to speak TSQL and make it easier to move apps that speak TSQL onto Postgres. I think they have tried to do some. Maybe they're working towards SQL Server stored procedure support. The problem is though that stored procedures in SQL Server speak TSQL essentially as their language, and in Postgres they speak PGSQL by and large. And I don't believe anyone has. There's no open source TSQL speaking stored procedure language for Postgres. Could you make one? I actually thought EDB had something like this years ago, and then I think they dropped it. They just didn't see the uptake like you do from Oracle. So I don't think there's anything out there now that does that, which ends up meaning that it's just a painful procedure, right? Like you do it kind of by hand. You look at your stored procedures and you rewrite them in Postgres. And most of the stuff you can actually do, and it works pretty well. I mean, you can rewrite it, right? Like the languages, like it's like tedious to do it, but it's not like impossible. You can read one and pretty easily figure out what to do in the other. The only thing that I find kind of lacking on the Postgres side, and maybe I don't 100% understand the interplay between tooling on the SQL Server side, is that SQL Server can do stored procedures that can return like multiple result sets. And in Postgres, I think the closest really is you can return a result set of ref cursors essentially. And I have an example of that in the Pagula sample database. And then what you do is say, like, you would start a transaction, run the procedure, and then you get these cursors back, and then you can open the cursors individually and scroll through them while you're in a transaction, right? Because it keeps the cursors in play. So it's kind of a painful way to re-implement that feature. I don't know how much that's actually used in SQL Server land. Like, I know it's used for some user-facing tooling that people might use. I don't know, like, if you're building an application, how much you would actually do stored procedures with multiple result sets. Because on the app side, it seems like an odd pattern to me to have your application call a stored procedure that's going to give you more than one result set back at a time and then do stuff with that. It's not like, I could see why you might do it. Just seems a little bit like maybe that's not a huge thing from an application developer's standpoint. So that's one to watch out for. There's probably others as well, but that's one I've definitely seen and might be an issue. So yeah, sadly there's no sort of easy like pass it in here and it spits out the other thing there. I'll admit, actually, this would be an interesting little experiment. Maybe I will play with this. Is if you ask something like ChatGPT isn't the right thing, but some kind of AI tool to say, hey, given this stored procedure in SQL Server, can you give me a Postgres version? I've not done that at all, so I couldn't say if it's even going to be remotely a usable thing, but it might get you like a shortcut of some of the way there, right? Of like, well, here's a stored procedure. I think what it'd probably do, because I've certainly looked at other examples of this kind of thing, and what I suspect it will probably do is give you like something that looks like a Postgres function with like TSQL stylings of SQL within it that won't actually run. So maybe that won't be as helpful as I would hope, but someday I'm sure it'll be magical, and maybe that's one of the ways. I'd certainly feel like you could train an LLM to do that specifically. That was really more focused on the sort of code and the rules about the language of TSQL and the language of PGSQL. So I don't know, something to think about. That might be an interesting little experiment to do. So yeah. So next question, also a SQL Server related question. What is SQL Server's equivalent of Postgres's CTID? If you've gone through my Think Like the Engine talk, my Think Like a Postgres talk, and I talk about CTIDs in there, and it's kind of this physical marker on disk. I think if you've watched the original Think Like the Engine talk, you will note that there is no sort of physical marker like that. And the way that it's typically handled in SQL Server, generally you would have index organized tables, and the index is on like a primary key column, that'll be like an integer, and then the integer sort of takes the place of the CTID, in that when you have an index, when you build a secondary index on your SQL Server table, which is already organized by the primary key, that secondary index will use the primary key like an ID column and reference that back to the original table, and it'll just map based on that ID. So it doesn't, whereas in Postgres, that secondary index is going to have the CTID as sort of the physical mapping of like, hey, I map back to this physical row. So that works great, for SQL Server when you're doing index organized tables, which is by and large the norm. I think that is what most people do. And seems to be a pretty good way to do it. You save a little bit of disk space, if nothing else. And Postgres just doesn't have that feature. So it doesn't do index organized tables. So if you do, my understanding is if you do a non-index or organized table in SQL Server, what it essentially does is it creates sort of a shadow ID And I want to say that this is also how InnoDB works in MySQL, but I could be misremembering that. It essentially creates a integer primary key that you just don't see under the scenes, and it uses that number in additional secondary indexes if you do sort of the unorganized, like sort of heap style table, which sounds a lot more like what Postgres does. So yeah, so that's sort of, I guess that's the equivalent. It is the ID column or the sort of hidden ID column in the SQL Server, and it doesn't map in the same way that the CTID maps, to the physical location. But for under the hood, like that's kind of the purposes of both. That's how it works. Those would be the interplay between those two things. So hopefully that is helpful. Hopefully you're not actually trying to do anything with the CTID that is user facing, and you don't need a conversion for some reason. That it could be scary, but that's if you're trying to understand the difference between the two, maybe that's helpful. Okay, fourth question. Why are apostrophes and asterisks usually restricted in databases? And I think this is generally true across, again, all the sort of major relational databases. That is true. Asterisks, I'm not quite as certain that they are restricted. Apostrophes, basically, this is just around like syntax parsing for both of these, really. And I think where people get in trouble with this is, again, in this case, this is a MySQLism where it uses like the sort of backticks and apostrophes. And I believe that's actually because the default collation for MySQL was originally like Swedish. And so for some reason, like that resulted in backticks being a thing. And so that's just sort of the common usage pattern. Whereas sort of in the ANSI standard SQL, right, like if you're going to quote like text data, you're going to use apostrophes. And if you're quoting like, relations like names of tables or things like that, like you would use sort of double quotes for that. And so these things the restrictions are usually just around like we have to be able to do some kind of syntax parsing. So there's escape mechanisms for that, right? Usually it's a backslash under an apostrophe to escape the apostrophe if you want to have, like a piece of text data that has that in there. Postgres also gives you dollar quoting as a feature. I think if you look up dollar quoting in the docs, I think that's actually the official name of it, where it's basically like, you'll see this language a lot in stored procedures, where you're like, create function blah as dollar dollar, and then you've got like the body of your text in there. So that's, that's a feature Postgres has to kind of make it easier to read this otherwise what might need to be escaped code with apostrophes and whatnot. With asterisks, like that's not a quoting thing so much as in regular expressions and the like syntax for the SQL statement, like if you're select all from users where name like Exila, something like that. So you can put asterisks around those likes to kind of change how that works. So depending on what kind of, if you have like support, which I think all of them do, and probably follow the same syntax for that, or if you have regular expression support, which I tend to use in Postgres, regular expressions rather than the like stuff, probably just force a habit from being old or whatever. Well, actually, in this case, it's probably because it's very sort of like Perl-esque, which I think Perl is where I first learned regular expressions. So if you don't come from a language that has a common usage of regular expressions, maybe you just use the like stuff and you go by that way, because they're like wildcards would be like percents and like, so versus like regular expressions, you'd have asterisks and whatnot. So I don't think there's really much other restriction on asterisks other than like the regular expression stuff generally. So other than you would have to quote it because it's a sort of a non-alphanumeric character. Like if you're doing a table name and you want an asterisk in it, which would absolutely be a horrible idea, and do not do that. But if you needed that for some god awful reason, you could double quote it, and I think that would go in. Like it's when somebody run that test and just make sure. I'm pretty sure you can do it as long as you double quote it, but absolutely do not do it. In fact, like I one of the like you have a list of like projects that you sort of feel like somebody might do at some point. that would be one where it's sort of like an event trigger or something in Postgres that looks at your SQL, and if it has like, create table with a name that has, like an asterisk in it or something, like you just throw an error and be like, no, you're not allowed to name tables anymore. Like you've clearly failed if you're trying to put asterisks in your table names. So yeah, I don't know. Maybe there's a good use case for that I don't know what that could possibly be. Okay, so let's go on. Last question of the day. Um, and this one, is again, I'm just going to go off the top of my head and answer this. But so the question is, what SQL join statements require an on clause, and which don't, and why? And so the way I'm going to answer this is actually none of them require an on clause. And I assume you're talking about like ANSI SQL join statements where you're like left join, right join, whatever. None of them require an on clause because you can have a using clause with all of them, and so then you didn't have to put in an on clause. So yeah, so there's a trick answer for your otherwise what I think is a reasonable question. Outside of that, I think they may not be required. Otherwise, I mean, you definitely should use. So I'm an ANSI join kind of guy, and this is probably one. It'd be interesting. Maybe I'll tell the PSQL Friday folks to do a topic on this as to are you an ANSI join or you're not an ANSI join. I'm definitely an ANSI join kind of person. I like to do that, and I would actually recommend using the on clause and not the using clause. It's just a little easier to read. And in cases where you have mismatched column names, you need the on clause for that if you're not going to like kind of litter your SQL with aliases and try to, do with clause or something to make everything to avoid that for some reason. It doesn't, again, would not really make any sense to do that. Anyway, so yeah, technically you don't need it, but I'm an on clause guy. I would say you should use them, and it just makes things easier to read and easier to reason about, and that to me is the more important thing. It's kind of an asterisk in the table name, right? Like you're causing yourself extra work for the rest of your life, so don't do that. And I know you're like, but I change jobs like every 2 years, so really this does not work for me for the rest of my life. I'm ensuring extra job market for future DBAs. So it's actually a good idea to do things like force people to double quote their names and use on clauses and have aliases all over the place and all that jazz. So, but no, actually, don't do that. Let's try to make future lives simpler. So, yeah. Anyways, so that's the answer to that. Use SQL join statements. Use the on clause. None of them actually do you have to. You can always use the using clause, and good luck with that. I think actually maybe with a cross join, maybe you don't need an on or a using clause. I wonder if there's a matrix if somebody's actually written this down. I think because with a cross join, like you could just like name two random columns, right? Everything's going to get joined against everything else. So if you are, that's a really good way to get subtle bugs into your brain. Like it's very odd that a cross join is the right answer with no actual matching, no specification of what you're cross joining on. So anywho, sorry for the ramble. All right, so that's our questions for the day. Two little bits and bobs to go into. Just want to remind folks I'm going to be at DevNexus next month. That is April 9th through the 11th in Atlanta, Georgia. So if you are going to be there, or if you're thinking about going, I would totally recommend it. It is a Java-oriented conference, so there will be a lot of folks who probably really like that language. Oddly, I am not one who really likes that language. I actually did a little bit of Java programming back in the day. Was not my favorite. Don't tell anyone. No mean to offend anyone. But in any case, we'll have a US Postgres booth there, probably some swag or whatnot as well. If you need like some stickers and all that good stuff, we'll be there and happy to answer more questions and talk about more Postgres stuff. That should be fun. The other thing I was going to mention, if you were ever inclined to do some contribution to the Postgres upstream community release, Postgres 17, the last commit fest is open right now. The last commit fest for 17 is open and feature freeze, I believe, is at the end of the month, April 1st. but there are still a whole bunch of patches that need to be reviewed. And you don't actually need to be like a super C whiz to help review stuff. You probably need a little bit of C knowledge, although even if you, and I would say that just to be able to like download and apply patches and compile Postgres. So you just, it's really more like git patch and make, or gmake probably, type of skill set that you need in order to do that than actual C knowledge. But even if you were just doing like nightly builds or something like that, and compiling them even after things have been reviewed and put in and testing, right? Because that's kind of the big thing. The earlier the feedback comes on these new features and whatnot, changes that are going in, the better for everybody. And in my mind, some of the best people to do that kind of testing are actual operators who are running Postgres every day and have an idea of like, well, here's some things that I might want to do or not want to do. And maybe most importantly, things that my business requires me to be able to do. So let me make sure these things still actually work. So you can start that, you don't have to wait till the beta release. I know a lot of people do. But if you want to get in and sort of contributing back to Postgres, that's actually a really great way to do it, is reviewing some of those patches that are out there. Just if you can compile it, run it, does it do what it says it needs to do? And are there cases, especially ones I used to tell people, like, go through and look for ones that you think are in an area that you in particular know that you already use. Like if you use a lot of partitioning, right, look for patches around partitioning, and go and just kind of test them out and make sure your stuff still works. Or if it breaks, like, is it meant to break in that way? And we have an incompatibility with the new release that's going to be coming out. So the actual release won't be out until, probably like September, October, something like that. So there's a lot of time before it hits the market. But like I said, if you've ever wanted to contribute upstream, that's a really great way to do it. And now would kind of be the time as we head into the last couple of weeks of the Commit Fest and Feature Freeze coming up. And we'll have a pretty good list of things. I'll put a link in the show notes, but it's commitfest.postgresql.org. You can check out the active Commit Fest and then see what patches are out there. There's still, like I said, there's still, I don't know, probably less 100 patches in the queue that need to get looked at and reviewed and committed, ideally. So, all right, that's it for this time. And let's see, just thinking about the calendar, I'll probably try to do one of these. Maybe I will do it from DevNexus if I don't do one before. That might be interesting, just to sort of give some impressions of what's going on up there. Otherwise, I'll definitely do one shortly thereafter. But that's it for this time, and I hope to see you again. Remember, as always, none of this is official database advice, just an old consultant giving out his opinions. And, otherwise, take care of yourselves, and if you can, take care of your database as well. See ya.